right, so it says for each of the composite functions, we need to identify an inside function and an outside function. Write the derivative with respect to x of the composite function. Okay, so let's call our inside function, let's call that maybe g of x, and let's call our outside function maybe f of g, because then we plug in g of x into here, and so our composite function then is f of g of x. And so that would be it. And then we'll take the derivative and we'll get f prime of g of x, or it's going to be, df dx when we're done. So that g kind of has to plug back in because we're going to have some kind of weird function. And so what we need to do is we need to find what gx is, and we need to find out what f of x, changing what I want to call it here, f of g is. Okay. Well, g of x again is the inside function, and that is usually what we look at what's inside of parentheses. So I would call that 4x squared plus 3. Now the outside function is what's left. Well, that's 6. Now I have to call all that g, and then that's to the fifth. Okay. Now I know when I do the derivative, I'm going to have to take basically and do df dg times dg dx to get my df dx. Okay, so I'm going to have to find those two derivatives. So let's go ahead and do that. So g prime of x is equal to what? Well, that's just going to be 8x, and this is going to be 30. Well, let's write it out here first. F of g is going to be 30g to the fourth, because we'll take the 5 down times 6 and then subtract 1, and we get our 4. And so then really our f prime of x is just equal to this times this. So we'll take 30g to the fourth times 8x. Now this is in g, we need it in terms of x, and so we have to replace that g with this. So we'll have 30 times 4x squared plus 3 to the fourth times 8x. Now, can we simplify this? Well, yeah, we could take 8 times 30 and get 240, and then x, and then times 4x squared plus 3 to the fourth. And then that would be our f prime of x. Or again, if we want, we could do df dx. So it's good to always remember those mean the same thing. So if you see find df dx, you're not lost. So knowing that those two things mean the same thing is going to be a key to help you there. And so that's our derivative of the composite function. And that's all we have to do. Again, at that stage there, that's also the derivative, but because it's simple, I went ahead and did to the final part here. All right, so again, using g of x as the inside, f of g as the outside, well, let's see. G of x is equal to, well, I think that's what I'm going to use for the inside here, 5x squared plus 8. And my f of g then is going to be equal to 2 ln of g. Well, guess what? We're going to do exactly the same thing. We're going to find g prime and f prime. So that's going to give us 10x. That's going to give us 2 over x. Okay. All right. Or not xg, because then that would cancel. So we don't want that. We need that g there still. 2 over g. So if we write this as df dx, that's going to be, we multiply this times this, 2 over g times 10x. Now we need to get rid of the g because we need it in terms of x. So that's going to be 2 over g, which is 5x squared plus 8 times 10x. Now remember, that's 10x over 1. So we can multiply the numerator and denominator and get df dx is equal to 20x over 5x squared plus 8. Okay, and that would then be our final derivative of the composite function, okay, which is this. So they've already made the composite function. We're uncomposing it, decomposing it into the two inside and outside, taking those derivatives, multiplying them, and then that gives us the derivative of the composed function. All right, how about this one? Well, as we've been seeing, I went ahead and wrote the hints in, but as we've been seeing a lot of the times, what we do is we take this up and we'll have this written instead, or in the case of the square root, we take it to the 1/2. Okay, so both of those are key things that we've kind of been doing a little bit of already. We've seen, and so we'll just continue with that. So with this one, we have our g of x is equal to the inside. Well, that's going to be my inside, x to the 5th minus 1. And my f of g then is going to be 3. And now, again, we're going to look at it in this fashion here. So it's going to be g to the negative 3. All right. Now, as we've been doing, we're going to find our derivatives of the outside and inside. So if we take the derivative of this, that's just going to be 5x to the 4th. Take the derivative of this, that's going to bring down a negative 3, so it's going to be a negative 9g to the negative 4. Remember, subtract one more off, so that's going to get larger in the negative sense. This one gets smaller because it's in the positive. All right, so that means df dx equals, or if we wanted to, we could write f prime of x is equal to what? Well, it's going to be this times this. So if we write our f first, it's going to be a negative 9. And if I go ahead and put that g to the 4th back in the denominator, then I can get rid of the negative because I don't always like negatives in my answer. And then times a 5x to the 4th. Now this g, I need x. So I need to replace the g with this. And so that's going to give me, well, let's go ahead and multiply that top. Negative 9 times 5 is in negative 45x to the 4th over, and now I have x to the 5th minus 1 to the 4th power. Okay, and so that would be my final derivative. So that would be my df dx. All right. Now, the next one is going to work almost exactly the same, except that we have that square root and we just have to rewrite that as the half. All right, so gx equals and f of g equals. Well, let's go ahead and call that whole thing inside there our g of x. So it's going to be x cubed plus 2ln of x. Now what's the going to be? Well, and now it's going to be 3g to the 1/2. Okay. Well, can we take derivatives of both of those? Yeah, sure, we can do that. Well, the derivative of this, first we'll take that derivative, so that's going to be 3x squared. And we take the derivative of that, that's going to be plus 2 over x. Okay. Now, this one, that's going to give us half of 3, so that's going to give us 3 halves, and then it's going to be g to the negative 1/2. Okay, so that gives us that. Now, what do? Well, we do like we've been doing, we multiply those two together. So we get df dx is equal to, and now we take and say 3 halves g to the negative 1/2, and then times 3x squared plus 2 over x. Okay. Now, we're going to take that down to the denominator, but it's going to have this in place of it because we can't have a g. And so this is going to give us 3 over 2, it's down here. Now this is going to go to the denominator 2, and it's going to be positive when we get down there, so I'm going to rewrite it as the square root. And that's going to be x cubed plus 2ln x. And then that's times still 3x squared plus 2 over x. Okay. Now, I could go ahead and simplify this, but this might be one of the cases where we start saying, okay, well, we'll just leave this as the product like that. I could go ahead and take 3 times that and 3 times that, but then I have that fraction here, so then it's going to start having to multiply and go on the bottom. So maybe at this stage, this might be one where I say, okay, that's where I'm done, and that's the correct derivative, and so we're done at that point. Okay. All right, so that's some of the things, and I think when we're going through these, if you start understanding how to do it, maybe go ahead and pause before I actually do it yourself, and then go and check yourself. Do you get the same thing as I do? Okay. All right, let's stop there, and then we'll see what we get on the next patch.